Okay, so we're solving equations. It means we've got to get the trig function with the x by itself, right? In some instances, it kind of gets confusing or it gets a little bit overwhelming because you're seeing these cosines. It gets a little bit weird to look at. So if you need to, just to kind of help you see it a little bit clearer, you can always rewrite this without the cosine in it. So 5x is equal to 3x plus the square root of 3. Just watch. You don't necessarily need to write that down, but I just rewrote that equation so that it doesn't have the cosines in it. I think looking at this equation over here, it's a little bit easier, a little bit clearer to see or figure out what you're going to have to do. So if you need to do that, then definitely do that. Take that extra step of kind of writing it out and solving without the trig function in there, and then go back and put the trig function back in. Okay, so in this case, we are going to subtract the 3 cosine x. And so we get 2 cosine x is equal to the square root of 3.
Divide that by 2.
And yep, then we've got to divide both sides by 2. So we get that the cosine of x is equal to the square root of 3 over 2. Now, for this one, let's go ahead and do the interval from 0 to 360 degrees. Like I said, most of the time we're going to go from 0 to 2 pi. We're going to give our answer in radians. But let's do degrees for this one. So handy dandy unit circle, x is equal to the square root of 3 over 2. What are our two solutions?
330 and 60.
Yeah, there we go. So we get 60, whoops, careful. Cosine is 30 degrees and 330 degrees. There you go. All right, these are still falling off. It's time to bite the bullet and hot glue them up. Okay. All right, are we good with that? The 30 degrees and the 330? Okay. All right, let's look at this next one then. I'm trying to get tan x by itself. So in this case, we're going to need to add 4 to both sides. And 4 minus 3 gives us 1. And then we're going to have to divide both sides by 3. So we get that the tan squared x is equal to 1/3. And then we're going to square root both sides. Now remember, when we take the square root of both sides in order to solve, we have to consider the positive and the negative. The square root of 1 is 1, and so we get 1 over the square root of 3. So when we rationalize that, we get that we're looking for tangent values of square root of 3 over 3. And we're looking for the positive and the negative. Let's do radians for this one. So let's go on the interval from 0 to 2 pi. So where are tangent values equal to the square root of 3 over 3 in radians? Pi over 6. Yep, keep going. Keep going, Ryan.
Pi over 6.
Yep, 5 pi over 6.
7 pi over 6.
And 11 pi over 6. So it's all of those, isn't it? Whoops, not 7 again. 11 pi over 6. There you go. Because we're considering the positive and the negative. Okay. Questions on either of those two? Okay, let's look at a couple with factoring. Everyone's favorite thing. Sometimes you're just factoring out a GCF, and other times you are truly factoring. So on this one, I'm going to move the square root of 3 sine x to the left-hand side. So I have 2 sine x cosine x minus root 3 sine x equals 0. So what's the common factor that we can factor out? Sine x. So let's factor out our sine x. And we're left with, on the inside, we're going to have 2 cosine x minus the square root of 3. Okay, so then we know to solve at this point, we set each factor equal to 0, and then we solve from there. So we're looking at where the sine of x is equal to 0, and then where that's equal to 0. So I want to add the square root of 3 and divide by 2. Let's do that in one step. I think you guys can see that okay. So we get cosine of x equals positive square root of 3 over 2. And then we also have to consider where the sine of x is equal to 0. Now we're doing this from 0 to 2 pi, so radian measures. So where is the sine of x equal to 0? Where? Okay, so yeah, okay, technically when we're writing this, I want you to notice the way that interval's written. So the bracket is at 0, and then a parenthesis saying it's not included at 2 pi. So really we want to write that as 0 or 0 pi. And then where else is sine equal to 0? At pi also, right? So 0 pi and pi for this one. So those are part of our solutions. We get 2 solutions for cosine of x equals square root of 3 over 2 also. Where is that? Yep, pi over 6. We're getting a lot of pi over 6s, aren't we? Not necessarily always the case. We're just getting lucky that way. I'm sorry, say that again?
11 pi over 6.
Yep, so the pi over 6 and 11 pi over 6. You want to include both of those. Okay. I want to adjust this one. So do me a favor and rewrite that so that this is, let's do this as cosines and not sines, because you've seen a lot with sines.
So this is kind of a lot with like just algebra and then
It is. It's a lot of just algebra there. All right, this is saying, so change those to cosines, but then this is one that I think it's helpful. If you think about what this is saying here, this is saying we have 2x squared plus x minus 1 equals 0. So we need to factor that. We'll go back and put the cosine x in there. But yeah, Katie, you're exactly right. It's a lot of algebra here now. But then we're extending it a little bit into the trig with not just x equals, but now cosine of x equals. So then you have to take it that one step farther. All right, let's factor this. I know I need a 2x and an x to multiply to get 2x squared. I know I need 1 and 1 back here to get the 1 for the back, but we have to figure out signs so that we get a positive 1x. That means this has to be positive, that's negative. All right, so in this next step, I want to rewrite so that I've got my cosine back in there. So I want to say 2 cosine of x minus 1 equals 0. And then 2 cosine of x, oops, I'm sorry, not a 2. All right, Ireland, pay attention. Cosine of x plus 1 equals 0. And we're going to solve each of these. So we get that. Cosine of x equals 1/2. And cosine of x equals -1. All right, so where are our solutions for this? Where's the cosine of x equal to 1/2 on unit circle? 2 places.
pi over 3.
There we go. Pi over 3, and where else?
And 3 3 is 5 pi over 3.
There you go, 5 pi over 3. And then where is the cosine of x equal to -1? Pi. Okay. All right. Questions, guys? No? All right, I want to point something out to you. In general, many times, any specific part of an equation is going to lead to two solutions on the unit circle, but in some instances, it ends up only being one. So I want you to realize that, like in this example, we ended up with two answers, that first one. In this one, we ended up with 4 answers. This one we got 4, and then this one we only got 3. So in terms of how many solutions you're going to have, you have to kind of be conscious of that, okay? All right. All right, I'm going to show you one example on this next page because there's kind of a trick to it. And it's this middle one here, number 5. So yeah, I'm going to put a little asterisk next to this because there's a little bit of a trick on this one. In some instances, I'm going to show you another example where we're going to do a substitution. You see 2 different trig functions here, and so you have to kind of be conscious of that. You have to think about how that's going to work out. In some instances, you can do a substitution. We have some identities that we can plug into, but in this particular case, kind of the trick on this one is to realize that we need to square both sides. And if we square 1, we know we just get 1. For the left-hand side, if we square that, we are going to have sine squared x. Here's the part most people forget. Minus 2 sine x cosine x plus cosine squared x. Okay, if you're not sure about how that came about, then off to the side here, make a note and FOIL this out. So do first, outside, inside, last, and you'll see how we get this minus 2 sine x cosine x. Okay. Now, why would we have done that? Why would we have done that squaring there? I saw that it was a single sine and a single cosine, but that when we square it, we get sine squared x plus cosine squared x. And what's that equal to, guys? 1. So that gives us 1. I'm going to highlight this so that you can see and remember where that came from. Minus 2 sine x cosine x equals 1. So now if I subtract 1 from both sides, I get this. So let's go ahead and divide by that -2. So we get that sine x times cosine x is equal to 0. So we have 2 different factors that are multiplying to get us 0. So that means we're looking at where sine of x is equal to 0 and where cosine of x is equal to 0. So where is the sine of x equal to 0? Brady, where do we look for sine of x is equal to 0?
Pi.
Pi, where else? Yep, 2 pi, only we're going to refer to it as 0 pi or just 0. Yep. So 0 pi and 1 pi. And then where is the cosine of x equal to 0? Cleo, where is that going to be? That felt good.
Yeah.
Where's the cosine of x? Remember, cosine's the x coordinate. Where is that equal to 0? Yep, pi over 2, and where else?
3 pi.
There you go, 3 pi over 2. Hopefully you're kind of seeing the connections too between when you find one value of thinking about where you're going to look for that second value in most instances, because you should be thinking, common reference angles there. Okay, so a little bit of a trick on that one. Oh, maybe we should do that top one. Yeah, let's do that one too. Because this has a substitution involved with it. Let's do this one also. So we're going to back up and go back and look at number 4. What I'm seeing on this one is I'm seeing sine squareds and sines, but then I'm seeing this cosine squared. So I want to rewrite this so that we have all of the same trig function if possible, just to kind of help out with that. So I'm going to rewrite that cosine squared. You guys thought you were done with these identities, and you have already kind of picked up on the fact that not quite. So I'm going to rewrite that cosine squared x as 1 minus sine squared x so that I have all the same trig function in this equation. Okay, so then I'm going to subtract the 1. I'm going to add the sine squared x. So 2 sine squared x minus sine x. Is that what we get? It looks like. Yep, equals 0. Because the ones add, no. Yeah. Does that look right? I have a mistake written in here on my paper, so that's why I'm kind of trying to double check myself here. All right, so sine of x is going to be 2 times sine x minus 1 equals 0. So sine of x equals 0. 2 sine of x minus 1 equals 0. So we get sine of x equals 1/2. I'm writing fast, so that's messy. Sorry. All right, so we're looking at where sine of x is equal to 0.
Zero
0 and pi. So these answers look somewhat familiar to what we just saw. And then sine of x is equal to 1/2. Yep, pi over 6 and 5 pi over 6. There you go. Thank you. Good. Yes. All right. How we doing? What do you think so far? Not too bad, right? Okay, let's take a look. There's 2 of them on this back page I want to show you. And then I'm going to ask you guys to work on the rest for homework. There is also a My Math Lab, so I'll talk with you about that here in just a second. Okay? So last page here. We're going to look at this one. And actually, we're not gonna do this one. I'm gonna have you do that one since I just showed you that example on the other page. I'll give you a hint. You have to do it. You're gonna use Pythagorean identity and substitute. Okay, but I do want to look at this one because this one, my suggestion is that you actually kind of use some logical reasoning skills on this problem rather than actually kind of trying to solve algebraically. Algebraically, it's kind of messy to try to solve, but I want you to think about how we can come up with the answer just kind of using some logical thinking for this.
Well, can you put one, like, do like the 1 over tan for the cotan?
You can, like I said, algebraically to solve this, it's just, I think it's prettier, and I think it's something you guys can do using some logical thinking rather than something algebraic on this one, personally. All right, if we're looking at tangent of theta being equal to the cotangent of theta, we know tangent of theta is y over x, and we know cotangent of theta is x over y. So at what special angle are our x and y values the same? Because that's really what we've got to be looking for, isn't it?
5 and 4.
Yep, so pi over 4. Where else? 5 pi over 4. Where else? How about 3 pi over 4?
I thought they weren't the same because one was negative and one was positive.
But in, like, if you look in quadrant 2 at 3 pi over 4, if you do y over x and think about what that ratio is, what the answer is, it's negative 1.
Yeah.
And then what if you did the cotangent there? You're going to be
It's still
doing,
-1.
it's still the negative 1, isn't it? So that's why it's going to be all of those, right? All of your pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay? There is also, I haven't mentioned this, there's a bit of a trick on this one. We'll talk about it day 2. Believe it or not, in some instances, it's not very fun and it doesn't happen very often, but I'll give you that hint also. But I want you guys to try those yourselves, okay? All right, so you've got a pretty good chunk of time here.